This video is in response to a specific question about a problem dealing with special relativity. And the prompt is, we're going to go to Proxima Centauri, which is 4.3 light years away. So Ly for light years. And we're given, of course, the distance, L0. So L0 means uncontracted. And then in the moving frame, this would be the contracted distance. And according to time dilation, the rest frame would be the extended or dilated time. And that's how come the moving frame has T0. So I know it's kind of unusual to have the zero in two different frames, but that's the note. This is the contracted one, and then this is the dilated one. Now, the other interesting thing too is about the units, so light years. So a quick note about using light years, especially this is a distance and not a time and not a speed. And then if we wanted to get a time out of it, time is distance divided by velocity, assuming constant velocity, of course. So if our distance is 4.3 light years, and we're divided by the speed of light, c, then the distance or the time it takes for light to travel 4.3 light years is 4.3 years. So we can really think about these units as simply canceling. So then this is equal to 4.3 years. Okay, well, let's finish things off here. We know that the moving frame is going to have a contracted distance, and it'll be contracted by a factor of L0 times our correction factor, which is the best way I can think of referring to it. That when we change back and forth from one frame to the other, we can apply this correction factor. And of course, distance divided by time should equal our speed. So we're left with this now, that L0 times the square root of 1 minus b squared over c squared over 4.0 years is equal to our speed. So the algebra for this is a little bit tricky, but not too bad. So let's go ahead and put in, we know that this is 4.3 years. And so the next step then is that we're going to have 4.3. So if we're trying to get speed, and we do speed equals distance divided by time, in terms of units, then that's going to be light years divided by years. And so again, years will cancel and we'll be left in terms of speed of light. So this is 4.3 c divided by 4.0 times the square root of 1 minus v squared over c squared equal to v. Right. So that's what happens to the speed of light. And so our answer is going to turn out to be proportional to c. So what do we do next? Well, we want to square both sides. And so we'll bring in a calculator really quick to do 4.3 divided by 4 and then square it. Okay, so that's 1.16 times the quantity 1 minus b squared over c squared. I don't want to forget the c is also squared, and that's equal to v squared. Okay, now it's an issue of collecting like terms. So when I multiply this out, I'm going to have 1.16 c squared minus 1.16 b squared equals b squared. And so I'll add this to both sides. And then, of course, I can divide both sides by 2.16. And while I'm at it, I will also take the square root of both sides to get v in terms of c. 0.16 divided by 2.16, and then take the square root. So 0.73. See, okay, that was helpful.